The year is 500 BC. My name is Pythagoras, and I am in Greece. Myself and a group of other mathematicians have figured out an important theory. It involves right triangles. We have determined that in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. This is very important. This theory, it has my name. It is the Pythagorean Theorem. It will help you find the side of a right triangle. It will help you see if sides make a right triangle. You will need your papyrus and a pencil and this new calculator. You will need a calculator. Watch the instruction videos, then rewatch the instruction video and work with them with the instructor. Good luck. Before we start getting into how to solve problems by using the Pythagorean theorem, how to find the lengths of sides and whatnot, which is what we'll be doing soon, I wanted to refresh you on a couple important factors. Remember, when we're solving equations, our goal is always to isolate that variable. And the way we do that is by using the inverse operations, or the opposites. When we have something like 3x equals 12, 3 times x, the opposite of multiplying by 3 is dividing by 3. So we divide both sides by 3, and it leaves us with just that x, because 3 over 3 is 1. When we had x plus 2 equals -9, we subtract 2 from both sides, because the opposite of adding 2 is subtracting 2. And we get x is equal to -11, because these two things become 0. Now, what you have to remember is that sometimes you're going to have things like this, b squared equals 16. Now, although squaring feels like multiplication, it's really not, because we're not multiplying by 2, but b squared, we need to get that b by itself. Remember, the opposite of squaring was square root. So if we take the square root of this side, this is going to leave us with just b. And if you think about that, it makes sense. Because if we take a number, let's say we take a number like 4 and square it, so 4 times 4 equals 16, but then we take the square root of 16, it brings us right back to 4. See, squaring and square root are the opposites. So when we take the square root of b squared, it gives us b. And then we have to take the square root of the other side, which gives us 4. So remember, when we take the square root of squaring, it gets that variable by itself for us. The one other thing to keep in mind is that you need to recall that whenever we have the square root of something that's not a perfect square, like say we have the square root of 60. Now, there are lots of different ways to find the square root of 60, and in some of the other videos you'll watch, it'll talk about leaving this square root of 60 with this radical sign on it. You don't have to do anything like that. For our purposes, you're going to take your calculator, you're going to type it right into your calculator, and you're going to round that to the nearest tenth. That's all we need to do. So when you take your calculator, you're going to put in 60, hit your square root key, and we get 7.7459. We round to the nearest tenth, which is right here. That 4 means to leave it right there, and we say that's approximately 7.7. Along with the help of a group of mathematicians that Pythagoras was working out, they put this idea of working with a right triangle and finding the missing lengths, they put it into words and developed what we know now as the Pythagorean theorem. What you see here, in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. This is the theorem. This is the theory that they developed. So let's explore what this is all about. So we start out with the opening line there. It states in any right triangle. So we got to know what a right triangle is. Well, that's a triangle where we have exactly one right angle. All right. It says the sum of the squares of the lengths of the legs. Well, we got to know what that all means. Sum means we're going to be adding some things out here. Squares means that we're going to be raising to the second power. But it's saying we're squaring the lengths of the legs. Well, we have to understand what's going on here. This triangle has three different sides. And those three sides, let's just for our purposes, we're going to label them A, B, and C. The A and the B, these are our legs. These are the ones that are called the legs. The ones that are connected to the right angle, they're called our legs. Now, this final thing that they talk about later on in the theorem, this word here, the hypotenuse, it's a really mathy sounding word. The hypotenuse is this final side. This side C here, that's your hypotenuse. And the hypotenuse is really special because that's the one side that's not connected to the right angle. It's actually always opposite the right angle. If you notice, it's across from that right angle. So that's how we identify the hypotenuse. But there's something else really important about the hypotenuse, and the hypotenuse is always going to be the longest. So it's always the longest. That's really important. So when you're looking at this, we can tell that our hypotenuse is always going to be the longest side. And it makes sense if you think about it. If you have two sides that connect to that right angle, the one that goes diagonally has to be longer than the ones connected to the right angle. So let's go back to the theorem. It states that the sum of the squares of the lengths of the legs. So just in general, our legs have a length of A and B. So if we square our legs, A squared, and add them, that states the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Well, our hypotenuse we called C, so we'll call that C squared. This formula right here, A squared plus B squared equals C squared, this formula is the formula that represents the theorem that Pythagoras and his band of merry mathematicians developed. So let's show how we can actually use that now. So when we're looking at right triangles, and this only works with right triangles. If we have a right triangle where we have two sides, for example, here we have a side 6 and we have another side 8. Well, we got to first ask ourselves, are these the legs or is one of these the hypotenuse? Well, because they're connected to the right angle, we know that those are the legs. We want to find that third side. Well, that third side would be our C, or our missing side. So here's how this works. We take our formula, A squared plus B squared equals C squared. And we're going to plug in what we know and solve for what we don't know. So here we go. We're going to plug in. Now, A and B don't matter. They're both legs, but we have to make sure that we plug in one for each. So we're going to plug in the 6 for A and square it. We're going to plug in 8 for B and square it. Now, we don't know what C is, so we're going to leave that right there, and that's ultimately what we're going to be solving for. So let's solve this thing for C. Do what you know. 6 squared is 36. 8 squared is 64. And that's equal to C squared. Don't skip steps. Now we can combine these two things. 36 and 64 give me 100, and that's equal to C squared. Now we're getting really close. We're at the point now where we need to know what C is. Now remember, we're going to use our inverse operation to get the C by itself. Well, it's saying C squared. If you remember, the opposite of squaring was to take the square root. So what we're going to do is we take the square root of this side, and then we take the square root of that side. Now the square root of a number squared, if you think about it, if you take a number, square it, and then take the square root, it just brings you back to where you started. So that gives us C. If we take the square root of 100, we get 10. So we're saying that C, our longest side, woohoo, has to be 10. There you have it. That's all there is to it. And it makes sense because our hypotenuse was our longest side. Let's do another one. So in this particular case, we have three sides of our right triangle. And it is a right triangle because we see that it has that corner there. And we're given a length of 8 and a length of 24. Now, in this particular case, remember, it's the legs that connect to form the right angle. 8 is connected to the right angle. 24, however, is not connected to the right angle. That one would have to be our C. Now, which one's A, which one's B? It doesn't matter. We can call 8 equal to A, and let's just call that B. Either way, it's not going to matter because we're just going to end up adding them at the end. But it's important we understand that 24 has to be our C because it's that one that's opposite the right angle. So we're going to want to find out our missing side. So here we go. We take our equation A squared plus B squared equals C squared. We're going to plug in what we know. Well, we said that A is 8. So plug in 8 here, and we're going to square it. Now, we don't know what B is. And C, we said, is 24, and we're going to square it. All right, so now let's start simplifying some things. So we've got 8 squared. Well, I'm pretty good at that one. I remember that. That's 64 plus B squared. We don't know that. Now, 24 squared, I don't remember that one, but fortunately, I've got my calculator right here. So I'm going to put in 24 times 24, and it gives me 576. So it's super important that you have your calculator with you when you're doing this. Even I'm pretty good at this stuff, and I need my calculator. So now at this point, we got to get the B by itself. Well, B's not by itself. Over here on the same side as the B, we've got that 64, and we've got it squared. Well, remember, we solve in the opposite of the order of operations. So first thing we're going to do is get rid of that 64. And we do that by subtracting 64 from this side. Subtract 64 from this side. On this side, these become 0, and we're left with B squared equals, well, 576 minus 64. Again, if you need your calculator, feel free to use it. Gives us 512. Now, I have no idea if that's a perfect square or not, but the beautiful thing about it is we've got this right here. And actually, if I turn my calculator sideways, I got my square root key. So I don't want B, I want the square root of that. So, sorry, I do want B. So I have to take the square root of B squared. That gives me B. And then I have to take the square root of 512. So I hit that on my calculator, and I get this big, giant mess. Look at that. So I've got 22.6274, blah, 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 blah. So what we're going to establish as our norm is that we're going to round off to the nearest tenth with any of our answers. Now, take a look. This is important. Remember, we said that the hypotenuse has to be our longest side, which even with what I got here, 22, sure enough, the 24 would be longer than that 22. So I feel pretty good about our answer. Remember, when you're rounding to the nearest tenth, we're looking at everything here. Doesn't mean just drop it off. We got to look at it because that is a 2. That's less than 5. So we don't push up to make it 22.7. We would say that B is approximately 22.6. And there we go. We found our missing side. Okay, so I do a lousy Pythagoras, but I gave it my best shot. I'm no Pythagoras, that's for sure. But at any rate, what we need to do is we need to take from that video is the idea that when you have your formula, your A squared plus B squared equals C squared, remembering A and B are the lengths of the legs. They're the ones that connect to make the right angle. And that third one, the C, is your hypotenuse. That's the diagonal one across from the right angle. And by plugging in what we know, we can solve and find the ones that we don't know. Now, there's going to be a bunch more videos for you guys to watch where you can see some more examples. Be aware of a few things. You're going to need paper and pencil. You're definitely going to need your calculator. Also, be aware that some of the videos you're going to watch are going to talk about how you can actually figure out a square root of a non-perfect square without using a calculator. We don't need to do that. You guys can just use your calculator. So if something says take the square root of 39, you don't have to use the method you're going to see in some of the other videos. Just type in 39, hit square root, and round to the nearest tenth. That's going to be perfect. That's what we're looking for. So watch these videos, give it your best shot, and have a great day.